Question number 11 on the worksheet on inclined planes, forces on inclined planes. Particle P and Q move on a line of greatest slope of smooth inclined plane. Okay, for smooth plane, that means there's no friction. Friction is equals to 0. P is released from rest at a point O. Okay, let's make that. So P is released from rest. That means for P, U is equals to 0. Okay. And there is a point O here. Let's say it's here. P is released from here. And 2 seconds later, so time is equals to 2. It passes through a point A. Let's say A is here. And at A, its speed is 3.5. That's going to be V. Find the acceleration of particle P and the angle of inclination of the plane. So to find A, we're going to use V is equals to U plus AT. 3.5 is equals to 0 plus A times 2. So A is going to be equals to 1.75 meters per second square. Okay, acceleration is done. Now we need to find the angle of inclination. For that, we're going to resolve the weight components. This is going to be mg sine theta, so 10 m sine 30. This is going to be the cos component of the weight, 10 m cos 30. This is always the normal contact force represented by R. And since the particle is going down the plane, this is going to be friction, but it's 0 in this question since it says it's a smooth inclined plane. Now we're going to use Newton's second law, which is forward force minus backward force is equals to ma. Forward force is 10 m sine 30. Sorry, it's not 30. Why did I write 30? It's theta. The angle is not given to us. So this is theta. And this is also going to be theta. Call it theta or x or whatever you want to. Theta. Okay. So 10 m sine theta minus backward force, which is 0 since there's no friction, is equals to mass times acceleration, which is 1.75. So m and m cancels out. Sine theta would be equals to 0.175. And theta would be equals to tan inverse of this, which is going to be, sorry, sine inverse of this, 10.07865. And correct to one decimal place, it's going to be 10.122. So this angle here is 10.07865 degrees. Okay. Next it says, at the instant that P passes through A, the particle Q is released from rest at O. Okay. So now P, the original particle, is here. This is P. And now this is Q. Okay. So at the instant that P passes through A, particle Q is released from rest. So now this is also at rest initially. U is equals to 0. This 30 is wrong. This 30 is wrong. It is theta, which we've already found. Okay. So at the instant that P passes through A, the particle Q is released from rest at O. At the time t seconds after Q is released from O, the particle P and Q are 4.9 meter apart. Okay, before we use this data, what I need to find is this distance between O and A. So I can use these and find S through this. Now we also know A. So we have many options to find the value of S. A is now 1.75 and now I need S. So I'm going to use S is equals to half U plus V times T. It's going to be half 0 plus 3.5 times 2, which is just 3.5. So that means this initial distance between the two particles is 3.5 meters. Okay. Now, after t seconds, let's say the first particle would have traveled this much distance, let's call it SP. And the other particle would have traveled, let's say, this much distance. Let's call it SQ. Okay. And at this instant t, the two particles are 4.9 meters apart. Let me replace these circles with dot, because the bigger I make the circle, the weirder the figure would look like, and the equations that I'm making might not make a lot of sense. Okay, so this is the distance covered by particle Q, and this is the distance covered by particle P. And at the instant t, these are 4.9 meters apart. That means I can say that, let me use a new ink. Okay, so this distance is 4.9 meters apart. Now what I want to do, I want to form an equation that has SP in it, 4.9 in it, SQ in it, and this 3.95 in it. So if you look at the equation, or if you look at the figure, notice that if I add this, which is 4.9, and this, which is distance covered by Q, this is the same length as SP plus 3.5. So let's form an equation using these, that if you add 4.9 and distance covered by Q, you get the same length as if you add distance covered by P plus 3.5. Okay. Now let's use the formula for distance, which is UT plus half AT square. Okay, so I know the U's here, I know the U here, we had found it earlier. It was 3.5, the V, which is now U, and this U is 0. So I'm going to use UT plus half AT square. So for Q, it's going to be 3.5 T plus half times acceleration had come out to be 1.75 times T square. Equals to distance covered by P is going to be UT plus half AT square. So 0 times T plus half. Its acceleration is going to be the same because it has the same forward and backward force, 1.75 T square. Now the T square terms cancel out. And we get 3.5 T equals 1.4. Okay, what did I miss? Okay, I missed at plus 3.5. I'm sorry, there was a plus 3.5 here. Okay, so this would become, okay, I noticed a mistake. Unfortunately, what I did was that this was SQ, which is right, but for SQ, the initial speed was 0. So this was supposed to be 0 here. And this is SP. So this is not 0. This is supposed to be 3.5. So let me fix that. Sorry about the mess up. Okay, that's why I was getting a negative time, which is incorrect. Okay, so now we have 4.9 is equals to 3.5t plus 3.5, which is 3.5t equals 1.4. And then when you divide 1.4 with 3.5, you get 0.4 seconds, which is the answer.